Hi friends, welcome to a co-engineering YouTube channel. Today we discuss about properties of probability distribution function. If capital Fx of x is a probability distribution function of a random variable x, these are the properties of probability distribution function. Now we have to see the proofs. Now we discuss the capital Fx of x minus infinity is equal to 0. This is the first property. Now discuss the proof of this value. We know that the probability of any event in a non-negative real number, probability of any event is non-negative real number in the range 0 and 1. The probability for an impossible event is always 0. We know that the impossible event never occur, that is x is equal to minus infinity. Therefore fx minus infinity is equal to p of minus infinity is equal to 0. That's why the first property is the value 0. Fx capital Fx into minus infinity, capital Fx of minus infinity is equal to 0 because of probability of event is non-negative real number in the range 0 and 1. The probability of for an impossible event is always 0. That's why the impossible event never occur x is equal to minus infinity. The second one here, fx minus fx of infinity is equal to 1. Fx of infinity with the positive value. Here the fx of infinity represents the integration of all probabilities up to x equal to infinity, that is the sum of all probabilities of x in a given sample space, which is always equal to 1. Therefore fx of infinity is equal to sum of n is equal to 1 to x equal to minus infinity to infinity, p of x is equal to 1. That's why fx of infinity is equal to 1, where infinity is a positive, the integration part. It represents fx of infinity represents the integration of all probabilities up to x equal to infinity. That's why that is the sum of all probabilities of x in a given sample space, which is always equal to 1. Therefore fx of capital Fx of infinity is equal to summation of x is equal to minus infinity to infinity, p of x is equal to 1. The third one, since the distribution function takes the value of all probabilities, the range of the distribution function is also the same as the range of probabilities. Here, since the distribution function takes the values of all the probabilities, distribution function, the third one is 0 less than or equal to fx of x less than or equal to 1. This is the condition. We have to prove of this condition. Since the distribution function takes the value of all probabilities, the range of the distribution function is also the same as the range of probabilities. Here, function takes the value of all the probabilities. The range of the distribution function is also the same as the range of these probabilities. Range of the distribution function is also the same as the range of probabilities. That's why 0 less than or equal to capital Fx of x less than or equal to 1. The fourth one, small fx of x. Here fourth one is capital Fx of x1 less than or equal to capital Fx of x2 if x1 is less than x2. Now I have to prove this condition. Fourth condition, fx of x is a non-decreasing function of x, since the distribution function is the sum of all the negative probabilities of set of x less than or equal to x. If x increases, then fx of x also increases. That is, the distribution function is a monotonically increasing function between 0 and 1. The distribution function is a monotonically increasing function between 0 and 1. It is known that the events set of x less than or equal to x1 and x1 less than or equal to x less than or equal to x2 are mutually exclusive. So the probability of the events like this. The fifth property is p of set of x less than or equal to x, capital X less than or equal to x2, x is equal to fx of x2 minus of fx of x1. Now discuss this probability 5. This is known as the event capital set of x less than or equal to x1, set of x1 less than x less than or equal to x2 are mutually exclusive. So the probability of the event p of set of x less than or equal to x2 is equal to p of x less than or equal to x1 mu x1 less than x capital X less than or equal to x2, p of x less than or equal to x2, p of set of x less than or equal to x1 plus p of x1 less than or equal to x less than or equal to x2, p of x less than or equal to x less than x1 x less than x2 plus p of x less than or equal to x2 minus of p of x less than or equal to x1. This condition have to be proof x2 minus x1. P of x of x less than or equal to x less than or equal to x2. P of x less 2 minus of p of x x1. If x2 is infinite, x1 is equal to x. P of set of x less than x greater than or equal to x, fx infinity minus of fx x is equal to 1 minus of fx of x. Now sixth property, fx of x star x plus is equal to fx of t fx of x. The sixth property, it states that the probability distribution function is continuous from x to x plus, where x plus is an infinitesimal increment in x. Fx of x plus is equal to fx of x. It states that the probability distribution function is continuous from x to x plus, where x plus is infinitesimal increment in x. Increment in x. This is the properties of probability distribution function. The first property is fx of minus infinity is equal to 0, fx of infinity is equal to 1. Now fx minus infinity is equal to 0, fx of infinity is equal to 1. The third property, 0 less than or equal to fx of x less than or equal to 1. The fourth property, fx of x1 less than or equal to fx of x2 if x1 is less than or x2. The fifth property, p of set of x1 less than x less than x2 is equal to fx of x2 minus of fx of x1. The sixth property is fx of x plus fx of x. These are the six properties of probability distribution functions. Thank you friends, thank you very much.